Hello everyone, myself Bhagwan Singh and welcome to our channel. Today we are going to discuss with the fundamental concept of calculus, which is differentiation. Whether you are a student struggling to grab the basics of this topic or you are looking to refresh your knowledge, so this video is for you. By the end of this video, you will understand what is differentiation and and you will learn how to use the differentiation to various functions. So let's start with the differentiation topic. Now, so first of all, I will ask what is differentiation? So I can say that the rate of change of function fx, or you can say y, with respect to the x is known as differentiation, right? With respect to x at any instant or a point, right? What it means? That means dy over dx, right? This is the change. This is the change in y over change in x at any instant or a point. Is it clear to you, students? So basically, now you must know about the slope, right? You must know about the slope. You must know about the average rate of change, right? Now, what is slope? Slope is this y2 minus y1 over x2 minus x1, right? And this is also written as f of x2 minus f of x1 divided by x2 minus x2, right? This is our slope, and we can say it as the average rate of change, right? Now it's look like this. So if let's say this is a point x1 y1 and this is a point b x2 y2, right? So this is our slope m. Is it clear to you? Now, if you look at here, now this is the average rate of change, but I am talking about different rate of change. I am talking about rate of change at a instant. That means I am talking about the rate of change at, let's say, at this point, at particularly point A, right? Is it clear to you? Now, so how we will do that? Now, so for that, let's move this point B towards A, right? Let's move this point B towards A such that it comes very, very close to point A, right? Let's say this is our new point B dash, and such that this is our delta x1, right? And this is our delta x, right? This distance is delta x. So can I say that B dash point is nothing but now x1 plus delta x, comma f of x1 plus delta x, right? This is our B dash now. So can I say dy over dx will be again same thing, f of x2, what was dy over dx? F of x2 minus f of x1 divided by x2 minus x1. So put it here. Now f of x1 plus delta x minus f of x1 divided by x1 plus delta x minus x1, right? Which is f of x1 plus delta x minus f of x1 over delta x, right? Now here the value of delta x. Now what I am doing, see here the value is very big, and what I am doing, I am reducing the value of delta x. So let's say I am reducing the value of delta x up to which point? This delta x is not 0.1. It's not 0.01. It can be as small as 0.00001. That means the delta x is tending to 0, right? That means I can take much more smaller values of delta x, right? So can I say that now if that means can I say that delta x will be moving towards 0? So can I use the limit? So limit delta x is tending to 0 f of x1 plus delta x minus f of x1 divided by delta x. This is our dy over dx at a instant. This is the differentiation, right? Okay, that means this is our instantaneous rate of change. Is it clear to you, students? Right? Now, moreover, further, I can say that dy over dx can be written as limit x tends to delta x tends to 0 f of x1 plus delta x minus f of x1 divided by delta x, right? This is instantaneous rate of change, and I can write it as limit x tends to 0 f of x1 plus x minus f of x1 divided by h. This is also written as like this, right? And this is known as, you can say, instantaneous rate of change, or this is also known as first fundamental principle of derivative, or you can say fundamental principle of derivative, or first fundamental principle of derivative. Fundamental this is known as first principle of derivative, right? Is this clear to you, students? That means what I am doing, let's say this is the slope. Now I am finding the slope at this point A, which is x1, y, right? How the slope is changing at this particular point A. This is the instantaneous rate of change, which is known as differentiation. Is that clear to you, students? Now let's take some more example. Let's take some more example, right? For example, let's say fx is equal to x, right? I have to find dy over dx. Moreover, also remember that dy over dx can be written as y dash, and this can also be written as f dash x, right? So I have to find dy over dx. Now, using the first fundamental principle. So what I will do now, dy over dx is f or limit x tends to 0 f of x plus h f of x plus h minus f of x over h. So can I say that? Now put the value limit x tends to 0, use the function. So can I say x plus h minus x over h, right? Which is nothing but limit x tends to 0 h by h, which is equal to 1. So can I say if y is equal to x, then dy over dx can be equal to 1. Is this clear to you, students? Right? Now, let's take one more example. Let's take one more example. Let's say y is equal to x squared, right? So again, we have to find dy over dx, right? Now, can I write limit x tends to 0 f of x plus h minus f of x over h, right? And apply the rule. So apply the first rule. Now put the value. So can I say this will be x plus h whole square minus x square over h, and this will be limit x tends to 0 x square plus x square plus 2hx minus x square over h, right? Now x square and x square get cancelled out and divide by h, so limit x tends to 0, so I will get x plus 2x, right? And if you apply the limit x tends x is equal to 0, so in that case I will get the value 2x, right? So can I say for y is equal to x square, the differentiation is 2x, right? Now let's learn some more about derivatives, right? Let's learn some more properties of derivatives, right? Now the first property is if y is equal to x raised to the power n, then dy over dx is equal to n times x raised to the power n minus 1. Now let's prove this using the first principle. Okay, so can I say now for first principle what I need dy over dx, right? What is first principle? Dy over dx, limit of x tends to 0 x raised to the power f of x plus h minus f of x over h, right? That means I need what's the y is our x raised to the power n. So what I need f of x plus h. So what is the x plus h? This will be x plus h raised to the power n, right? Now if you remember the binomial theorem, we can apply the binomial theorem here. So this will be x raised to the power n plus n times x raised to the power n minus 1 h plus n times n minus 1 over 2 factorial h square x n minus 2 plus up to h raised to the power n. This is also the binomial expansion of x plus h raised to the power n, right? Now we can apply and we can put the value here, right? So put the value, can I write limit h tends to 0, this will become x raised to the power n plus n of x raised to the power n minus 1 times h plus n minus 1 x raised to the power n minus 2 x square divided by 2 factorial plus up to h raised to the power n minus of fx, that is x square, right, divided by x, sorry, not x square, x raised to the power n. So can I say x raised to the power n minus x raised to the power n cancel out? So this will be limit f tends to 0. Divide everything by h as well. So this will become n times x raised to the power n minus 1 plus n minus 1 divided by 2 factorial x raised to the power n minus 2 h plus, and this will become x raised to the power n minus 1. Now you can see that the first term is free from h, right? However, all the other terms will have h, right? So when I apply the limit, when I put the s tends to 0, so what will I get? I will get n times x raised to the power n minus 1, and all the terms will become 0. So can I say this is n times x raised to the power n minus 1? So always remember that. So can I say that y raised to the power y is equal to x raised to the power n, then the differentiation is n times x raised to the power n minus 1. Now, you can apply this general rule in all the algebraic function. What I am saying, you can apply it in all the algebraic function. Right now, let's see the same formula using the previous questions we did. Right. So the first question we did is the first question was y is equal to x, right? And when I solved this equation using the first principle, I got the value 1. Now let's use the general rule, right? Which is y is equal to x raised to the power n if then the differentiation is n times x n minus 1. So if you put it here, you can see that n is equal to 1. So y dy over dx is equal to n. Put it here 1 times x raised to the power 1 minus 1, which is 1 times x raised to the power 0, which is nothing but 1. Now from here, you can also see that we are getting the same differentiation. Is this clear to you, everyone? Okay, let's move ahead. Now, so let's see the second example, y is equal to x square. Now here you can apply the same rule, right? You can say dy over dx n is equal to 2. So can I say this is 2 times x raised to the power 2 minus 1, which is 2 raised to the power 2 times x, 2x, right? And remember using the first principle. At that time as well, I was getting dy over dx as 2x. That means this is our this rule works 100%, right? Then I say that this rule works 100, right? Now, moreover, let's move to some more. Let's move to some. Okay. Moreover, let's move to some of the more examples, right? Now, some more rules as well. See, if y is equal to c is any constant, right? C is any constant, right? Then dy over dx is equal to 0, right? Similarly, we have some trigonometric function. See, if y is equal to sin x, then dy over dx will be cos x, right? Similarly, fourth one, if y is equal to cos x, then I can say dy over dx is equal to minus sin x, right? Perfect. Similarly, the fifth rule is if y is equal to 10x, then dy over dx is equal to sec square x. Sixth, if y is equal to cot x, then dy over dx is equal to cosec square x. Right? Now, similarly, I will drop more rules here as well. Okay, so you can see some more rules here as well. Just remember them or note down them. Right now, similarly, we have some rules for exponents as well. So if y is equal to e raised to the power x, then y dash or dy over dx dx is e raised to the power x as it is. Similarly, if I have y is equal to a raised to the power x, right? If I have y is equal to a raised to the power x, then dy over dx is equal to a raised to the power x ln a. Getting it? And similarly, we have some log function. So if y is equal to log of x with base b, then dy over dx is 1 over x log ln b. Right? This is 1 over x times ln b. And similarly, if y is equal to ln x, then dy over dx is 1 over x, right? See, I can write it as 1 over x times ln e, and ln e is nothing but 1. This value is 1, so I can write it as 1 over x, which is this part. Right? So is it clear to everyone? Okay. Now you might wonder how this is happening, right? How this is happening? How all these are happening? So let's solve this function y is equal to sin x and its differentiation is cos x. Let's solve this function and see what we get using the first principle. Right now we only know the first principle, right? So can I say if y is equal to sin x, right? So what will be for dy over dx? Can I what I need? I need limit x tends to 0 f of x plus h minus f of x over h, right? Yes. Now what I need? So put the value in the function. So what I will get? Sin x plus h minus sin x over h. Getting it? Now, if you remember your class 10, you learned about the sin c plus minus sin d. You must, everyone know the rule, right? Everyone know this rule, right? What is sin c minus sin d? So that is 2 cos c plus d by 2, right? I will write it again, 2 cos c plus d by 2 times sin c minus d by 2, right? So sin c minus sin d is 2 cos c plus d by 2 and sin c minus d by 2. So can I apply it here? Right? Now apply here. So I have sin x plus h minus sin x. So I will get 2 cos x plus h minus plus x times sin x plus h minus x divided by 2 divided by 2. So I will get 2 cos 2x plus h by 2, right? And times sin h by 2, right? And can I write it as like this? So can I write it as cos x plus h by 2? Can I write x plus h by 2 cos x plus h by 2 sin h by 2? Now put the value here. Now if you put the value here, what you will get? Now you will get limit x tends to 0, limit x tends to 0, 2 cos x plus h by 2 times sin h by 2 divided by h. Right? Now rewrite it again, arrange it. Okay, so can I write it as cos x plus h by 2 times sin h by 2 divided by, can I write it as like this, divided by h by 2. This is the same thing, right? And if you put it here 0, so this will become cos x, right? And this will become limit x tends to 0, s tends to 0, sine x by 2 divided by h by 2, right? And this value is nothing but our 1, right? So this is our cos x as we know that limit of limit of x tends to 0, sine of x over x is 1, right? So using this rule here, x is equal to h by 2, right? So if you put h by 2 in this place, so this limit will become 1, so the answer will become cos x, right? So can I say now, are you getting it? So can I say if y is equal to sin x, then dy over differentiation of sin x will be cos x, right? Similarly, students, you can solve for a function cos x, you can solve for function tan x, and you can solve for any of the trigonometric function, any of the exponential function, log function, using the first principle of derivative, right? I hope this is going clear to you, right? Let's discuss about some more rules of differentiation, right? So the first rule is addition and subtraction rule. Then second we have multiplication rule. Third we have quotient rule. And at the end, we have chain rule, right? Now, let's say if we have y is equal to, now, let's say if we have two functions, right? F of x plus minus g of x, right? Then y dash will be equal to f dash x plus minus g dash x. This is known as our differentiation, this is known as our addition and subtraction rule of differentiation. That means we can easily distribute the differentiation rule on the function. Let's talk about multiplication rule. So if we have y is equal to f of x times g of x. Now, how will you remember this rule? So for remembering this rule, I will say this is the first function and this is the second function, right? So how will I learn? How will I do? Y dash is equal to first function, differentiation of first function, second additive plus first function additive, differentiation of second function, right? This is our multiplication. So how will I write? First differentiation of first, second additive plus differentiation of second, first additive, right? So you have to write in the same order as well. Okay. Similarly, if we have function in the form of quotient fx over gx, right? Again, I will write it as y dash is equal to, again same thing. This is our first function, this is our second function. So first function, differentiation of first function, second additive minus differentiation of second function, first additive divided by gx whole square, right? So again, both the rules are same. The only difference is in multiplication rule we have addition, in quotient rule we have subtraction, and we have one more term which is denominator whole square, right? So how will you learn? How you can learn as well? Differentiation of numerator, denominator as it is, denominator differentiation of denominator, numerator as it is, and divided by denominator square, right? Similarly, we have the chain rule, right? So if let's say now let's move to the next slide. Let's discuss the chain rule here. Right. Now let's say we have composition of function. Composition of function. So what is composition of function? If I write y is equal to f of g of x in this form, right? This is known as composition of function or form function, form x. So in this case, now I have to find dy over dx, right? But the y function, the f function is the function of gx, not the x. But we are differentiating with respect to x. So what I can do is, now I can put x is equal to, now I can put, we will assume the inside function, that is gx, let gx as t, right? Let gx as t, and I can see that now let gx as t and t is equal now, and g dash, now do the differentiation, so g dash will be dt over dx, right? Now when I put gx as t, what I get? I get y is equal to f of t, right? Now I can't differentiate the t with respect to x because y is the function of t now. So can I write it as dy over dt times dt over dx? I did nothing, but I just multiplied and divided by dt, which cancel each other, right? So which is eventually dy over dx, right? Which is eventually dy over dx, right? So I am not doing any changes, but I am just multiplying or dividing it, right, with dt. So this will be now dy over dt is f dash t, right, and dt over dx will be g dash, right? So this is, now can I put the value of t again? So this is g dash of g of x times g dash x, right? So this is how the chain rule works. This is how the chain rule works, right? Okay. Now, so this is our chain rule, right? This is our chain rule, and you can also say that. See, what is this? Y is equal to f of g of x. So can I say that differentiation of fx, right, times and then inside function that it is, and then differentiation of g inside function that is g dash. Let's do one question from this side, right? Let's say we have, let's solve a question. Let's say we have 6x square plus 7x raised to the power 4. Now you can see that this is the composition of function because this is another function and the power is another function, right? How? So if I say fx is equal to x raised to the power 4 and gx is equal to 6x squared plus 7x, then our f of g of x will become this f of 6x squared plus 7x, right? And this will become 6x squared plus 7x raised to the power 4, right? See, so can I say this is composition of function, and in the composition of function, I told you that you can put the inside function as t. So I will put t as 6x squared plus 7x, right? So dt over dx will be, now the differentiation, this will be 6 times 2x plus 7, which is 12x plus 7, right? Yes? And now, so I have, now dy over dx will be, t, now the y function will become t raised to the power 4. So can I write dy over dx as dy over dt times dt over dx, right? Which is, now t, do the differentiation of t raised to the power 4, which is t cube, 4 times t cube times dt over dx, and I can put the value of dt over dx from here, that is 12x plus 7. And now you can just put, now you can just put the value of t. So I will get 4 times 6x square plus 7x raised to the power 4 times 12x plus 7. This is how our chain rule works. I hope this is clear to you everyone. Okay. Now, let's discuss. You are wondering why is it, how the chain rule, how. Now we learn the addition and subtraction, right? We learn addition and the subtraction rule, right? So what was that? Y is equal to f dash x plus minus what was the subtraction, addition and subtraction rule? Y is equal to, or let's say fx is equal to ux plus minus vx, then f dash x is equal to u dash x plus minus v dash x. Right? Now let's solve this using the first fundamental principle. So dy over dx will be, now dy over dx will be limit x tends to 0 f of x plus x minus f of x over h. Right? So can I say limit x tends to 0, f of x plus h will be u x plus h plus minus v x plus h minus u of x plus v of x divided by h. Now write the unit terms together. So this will be x plus h minus u of x divided by h plus minus limit x tends to 0 v of x plus x minus v of x divided by h. And you can see that this will be, now as you can see that this will be u dash, this is nothing but u dash x and this is nothing but v dash x. So I can say that if we have for any function in the sum of two functions, then we can then the differentiation is also the sum of differentiation of both the functions. So let's see one more question from here. So let's say we have y is equal to 6. Let's say we have y is equal to 6x raised to the power 4 minus x cubed. So can I say dy over dx will be differentiation of d over dx of 6x raised to the power 4 minus d over dx of x cubed, and this will be equal to 6 times x raised to 6 times 4 times x raised to the power 3 minus 3x squared. So it is I hope this is clear to you students, right? Similarly, let's discuss product rule. This is we can see that this is the product of two functions, right? Now, so can I say dy over dx is equal to, now this is first function, this is second function. So product, can I write second function as it is differentiation of first function plus first function as it is times differentiation of second function, right? So can I say this is 3x minus 2 times, can I write 2 plus, and this is 2x minus 1, and can I write 3, yes, and this will become twice of 3x minus 2 plus 3 of 2x minus 1, and if and you can simplify, this will be 6x minus 4 plus 6x minus 3, and which will be 12x minus 7. So the differentiation of 2x minus 1, 3x minus 2 is 12x minus 7. I hope this is clear to you, right? Now, let's do another question from the quotient rule, right? Now, if I say dy over dx is equal to 2x minus 1 over x raised to the power 3 by 2. Right? Now, you can see that this is our question, and what was the quotient rule? The quotient rule was dy, if y is equal to f of x divided by g of x, then dy over dx is first function differentiation of first function second additive minus differentiation of second function first additive divided by denominator square, right? So this is our first function, this is our second function. Let's write dy over dx, right? So can I say differentiation of first function, so d by dx of 2x minus 1 times second function as it is minus first function as it is d by dx of second function divided by x 3 by 2 whole square. And now you can see that this will be, now you can see that this will be 2 times x raised to the power 3 by 2 minus 2x minus 1, and this will be now 3 by 2 x raised to the power 3 by 2 minus 1 divided by x. So just simplify this one. So can I say this is 2 3 by 2 minus this will be 1 by 2, right? So can I say 3 by 2 of 2x minus 1 times x raised to the power 1 by 2 divided by x cube. So this is the example of the question. I hope you are getting it. I hope you are getting it and you are understanding all the concept and the rules of differentiation, right? So everyone, that's it for today. I will see you in the next lecture. Bye bye.